today's video, we are going to continue factoring quadratic expressions using our factoring methods or our factoring friends. In our last video, you met 3 factoring friends, and in today's video, we're going to introduce you to 2 more very helpful factoring friends. Your first friend, the friend that you were always going to ask for help, is greatest common monomial, and that's kind of like reverse distributing. So you always look for a greatest common monomial factor in all terms of any quadratic expression, or any expression really. Friend 2 was a difference of 2 squares, which when you recognize that it was a difference or the subtraction of 2 perfect squares and you factored it, it was factored into 2 binomials. Those binomials were called a sum and difference pattern. And your third one was the perfect square trinomial, where the first term and the last term were both perfect squares. And if you took the square root of those, multiplied those square roots, doubled them, you got your middle term. And when you factored a perfect square trinomial, you got a square of a binomial factor. Your fourth factoring friend, or factoring method, has a split personality. This factoring friend, guess and check, is really helpful when the leading coefficient of your trinomial, once it's in standard form, is equal to 1. So when your leading coefficient, or in other words, when A is equal to 1, then all you have to do is you're going to look at C. You're going to find factors of C whose sum, whose inners and outers, will add up to give you B. So in other words, if you factor it out into 2 binomials, your inners, which are px, and your outers, which are qx, will give you a middle term of bx, right? You want this b. All right, so let's give this a shot. And this is actually fairly simple. So I look at this quadratic in example 1. I first of all say to myself and ask friend number 1, greatest common monomial factor. Are there any greatest common factors in those 3 terms? And there aren't. Great. So now I'm going to look at C. And C in this situation is 24. And I'm going to ask myself, are there factors of 24 whose sum or difference, right? If I put them in inners and outers, I'll get the middle term equaling to 10. So some of you guys have done this before using, for example, a diamond problem. Maybe you wrote something where, hey, I have factors. I have 24. I need factors of 24 that'll add or subtract to give me 10. And it works really nice when you have this first personality where the leading coefficient is equal to 1. Okay, works pretty simple. So I know that there are factors of 24, for example, 6 and 4, that'll give me 10. So I can quickly factor this into 2 binomials. I know that my first terms, when I multiply them, have to give me x squared. So really, I just take the square root of x squared, which is x, and place them in each first term location. And then I take the factors of 24, 6 and 4, place them in the last locations. And then I figure out what my signs have to be. So if my inners are going to give me 6x and my outers are going to give me 4x, then I know for a fact I need 10x as my middle term. So 6 and 4 should both be positive to produce that result. That wasn't so bad. It gets a little bit more tricky if you don't know factors of C, but still not that tricky. So example 2. Remember, don't forget about your friends that you've already learned about and that you've already met, okay? They're going to be super helpful. So I look at example 2 and I ask myself, can the greatest common monomial help me out? Yes, they can. So the first thing I notice is that there is a common factor of 2 in all 3 terms. So I'm going to factor out a 2 or undistribute that 2. And look, I'm right back where I started with in example 1. So keep the 2. Do not lose your greatest common monomial factor. It becomes quite important. It's actually a dilation factor when we start graphing these. So it tells us that it's going to be taller than its parent graph. And we'll talk way more about that in the future. So I'm going to factor this into two binomials just like I did before. I knew that factors of 24 that would add up to 10 were 6 and 4, and they both had to be positive. Now, I can check all of these, right? I can go back through just like I did up here, make sure that my middle terms match, make sure that my first terms and last terms also match the original polynomial that I was given. And in this one, once I get back to x squared plus 10x plus 24, I'd want to multiply or distribute that 2 back to make sure that I get what I started with. And in fact, I do. And you can check on your paper, but you can also check in your head a lot of times. Okay, now the diamond's not always the easiest way to go. So you want to make sure that you're familiar with factors and being able to write out a list of factors. So for example, with 24, I would have had 1 and 24, 2 and 12, 3 and 8, 4 and 6. Okay, so you want to be able to make these lists of factors because when friend 4 gets a little bit crazy and has the personality where we don't like to hang out with this friend doesn't become so easy to get along with. So this is where A is not going to equal 1. It becomes a bit more tricky here. You'll be looking for factors of C, and those factors will be exactly the same. They're still going to be P and Q. But you're also going to need to be looking for factors of A now. So you're going to look for factors of A, and those factors are going to coincide with what you're going to put in the first term. So those will be your M and your N. So what's going to happen here is you're going to guess where to put the factors of A and where to put the factors of C. And then you're going to check to make sure that your inners and your outers, in this case you'd have P times NX, and your outers will now be Q times MX. And when they add up together, you better get that middle term of B. Okay? So that's the hard part because you're dealing with so many different factors. All right, so let's look at example 1. So I look at example 1. It's a trinomial. It's a quadratic. Is there a greatest common monomial factor? No. All 3 terms cannot be divided by a common factor. Great. I know it's not a difference of 2 squares. I know it's not a perfect square trinomial because A and C are not perfect squares. Okay, so it must be guess and check. And because my A is not equal to 1, I know that this is going to be a more challenging one. That's okay. Don't worry. We are going to look for factors of 3 and factors of 5. So the factors of 3 are like what you have here underlined in blue, the M and the N. Now, luckily, this first example, we got a bunch of prime numbers, right? 3 and 5, they only have factors of themselves and 1. So it's going to make it a little bit easier to work with. We're going to factor this into 2 binomial factors. And we are going to guess where to place our first terms. Our first terms have to multiply to give us 3x squared, right? So these 2 places right here have to have the 3 and the 1, and they both have to have an x in them. So how about I just put 3x here and x here? You could have switched those, that would have been fine, but they got to be in the first places. Now the factors of 5 have to go in the last places because when I multiply the last places, they're going to have to multiply to give me 5. And I'm just going to guess. I don't know. Let's pretend that I'm just guessing here. And we all write with pencil. So I'll guess that 5 goes in the middle, or 5 goes in the first binomial, and 1 goes in the second binomial. And I don't assign any signs yet. I just check. I'm like, okay, inners would give me 5x. Outers would give me 3x. So if I add that together, I'm going to get 8x. If I end up subtracting one of them, I'll end up with 2 or negative 2x. So that's not going to work for me. So we erase. Okay, that one didn't work. Maybe I should switch where I put 5 and 1. And just change one thing at a time. So I'm going to now put 1 in the first binomial and 5 in the second binomial. I get 1x. I get 15x. Anyway, I can get a middle term of 16x. Yep, if they're both positive. That is completely factored. Wonderful. That wasn't so hard. Let's do a more challenging one. Example 2 with friend 4 where a does not equal 1. All right, so I have a trinomial. It's a quadratic. The first thing I notice is that there is a greatest common monomial factor. In fact, all 3 terms can be divided by 2. I'm going to factor out a 2 first, leaving me with 14x squared, negative 15x, and negative 9. I'm going to continue factoring. So I look at my trinomial. It is a quadratic. It's got x squared. Awesome. I notice that it's a trinomial, so I can't use difference of 2 squares. And my first term's not a perfect square, so it's not going to be a perfect square trinomial. So it is going to be guess and check, and my leading coefficient is not equal to 1. All right, so I'm going to keep the greatest common monomial factor of 2, and I'm going to break this trinomial down into 2 binomials. Now, I need to go over to the right here, and I'm going to list factors of 14, and I'm going to list factors of 9. And I'm going to try and figure out some combination to put these factors and get a middle term of negative 15. All right, so I'm going to have, let's see, 14 would be 1 and 14. 2 and 7. 9 would be 1 and 9, and 3 and 3. And I need a middle term of negative 15. So when I look at this, I could do this many ways. Let's say I choose 1 and 14. Well, 1 times 14 needs to give me my first term, 14x squared. So I could choose to put 14x here and x here. Right? And then maybe I choose 1 and 9. Or, you know what? Let's choose 3 and 3. All right. I try that. Well, right away, look, my outers are 3x. And my inners, ooh, what is that? 42x? All right. If I add those, I'm going to get 45x. And if I subtract them, I'm going to get 39, or negative 39, or 39 and x. Who knows? Depends on where the negative sign goes. I don't think that one's going to work out because I want a middle term of negative 15x. All right, so let's change something here. I think I want to change the 14. That seems like a really big number. So instead of using 1 and 14, let's try using 2 and 7. Oh, and I need the x's because when my first terms multiply, I got to get an x squared. All right, so let's see. My inners give me 21x. My outers give me 6x. Any way to get negative 15x from that? If they're both positive, I'm going to get 27x. If I take the difference, there's a difference of 15. I need it to be negative. So I think the 21 needs to be negative. So I get a negative 15x. All right, to make the 21 negative, the inners have to multiply to negative. So I need a negative 3 in the first binomial, positive in the second. And I think looking at this, if I check my first terms, I get 14x squared. If I check my last terms, I still get that negative 9 that I started with in the previous trinomial. So I will end up back to this trinomial and distribute the 2, and I'll get right back to where I started. So the factorization of example 2 of that trinomial is this. All this other writing is just me checking my work, okay? And it's checked out. Great. I'm not going to get this wrong on a test. Last friend is called factor by grouping. And there are many times where you might use this, but the most pronounced time is when you have 4 terms. Okay, so we have 4 terms here. I noticed that if I group, well, actually, I didn't even check in with my first friend. Let me do that first. So friend number 1, greatest common monomial, can you help me out? Well, all 4 terms do not have a greatest common monomial. So no, it's not a difference of 2 squares because it's not 2 terms. It's not a perfect square trinomial. I don't actually see any perfect squares in here. Guess and check's not going to work. Those work for trinomials. So I think it's a factor by grouping. And here's how this works. Group 2 terms at a time. Any 2 terms with a common factor. Okay, so I noticed that my first 2 terms have a common factor of 3x squared. And my last two terms have a common factor of 5. So I'm going to group those using grouping symbols, parentheses. Okay. In the first grouping, I am going to undistribute that common factor. So I am going to distribute out, or undistribute, sorry, 3x squared. So in this first grouping, let me make some colors here. So in this first grouping here, notice I factored out a 3x squared. What is left? So in other words, 3x squared times what gives me 3x cubed? I need an x. Okay, and then 3x squared times what gives me the second term of 12x squared? Well, I need a positive 4. So all of this now is a term that I created by factoring out the greatest common monomial factor from the first two terms. Now in the second two terms, I'm going to factor out the greatest common monomial factor, and the goal is to be left with a common binomial factor, a common factor that is a binomial. So in these two terms, I can factor out a positive 5, and that leaves me with an x plus 4. All right, so what I just did was I took that second grouping, right, and I grouped out of it, or I undistributed out of it, the common factor of 5. Now watch this. Do you guys notice that there's a common binomial factor? Because there's actually just two terms here. Okay, I have one term here and one term here. And there is a common binomial factor in both of these terms, and it is x plus 4. So I am going to undistribute the x plus 4. And this might blow your minds away. I'm going to take that x plus 4 and I'm going to factor it out, or undistribute it. And then I'm going to ask myself what's left. So x plus 4, this whole quantity x plus 4, that whole binomial, times what gives me this first term? Gives me this term right here. Times what? Times the 3x squared. And x plus 4 times what gives me this whole second term here? I need a positive 5. Now just double check. Are your two factors, notice you got two binomial factors here. Are these two binomial factors completely factored? Are there any greatest common monomials? Is it a difference of two squares? Anything, okay? These look completely factored to me. Now, can I come over here and check it? Of course I can. Now, these would not be two binomials that I can necessarily FOIL, because I don't have, in both of my binomials, the same variable part, okay? So when I distribute, I actually need to like double distribute, or distribute every term in the first binomial to every term in the second. All right, so when I check this, I get, looks like 3x cubed, positive 5x, just distributing. I'm going to do this one. I get 12x squared and a positive 20. And if I wrote that in standard form, I'd have exactly what I started with. So in fact, it does work. You can always check these by multiplying them back out. All right, let's make it a little bit more tricky with example 2. So first of all, I'm going to look through all of these four terms, and I'm going to ask myself, is there a greatest common monomial factor? And in fact, there is. Let's see, I think I see a 3 in every single term, a 3 factor, and a y factor. So I'm going to factor out 3y. What does that leave me with? Well, let's see, I got an x cubed plus an x squared minus a 4x minus 4. Now, the part of this that's left in the parentheses is a quadrinomial, so 4 terms, right? The only way I'm going to be able to factor something with 4 terms right now, later on I'll show you other ways, but right now is factor by grouping. So I'm going to look for terms with common factors or common monomial factors that I can factor out. And I notice that in my first two terms, x cubed and x squared, they both have two x's in common. So I'm actually going to group those. So I'll go ahead and I'll use another set of parentheses. Actually, what I should probably do, why don't I make these original parentheses that I created some brackets so things stand out a little bit better. So I'll group my first two terms. Now this is going to get a little bit tricky, so pay attention. Notice that my third term is a negative. I'm going to keep that negative sign with my third term. Okay, so when I group my second grouping, I'm actually going to group it with the -4, and I'm going to remind myself this is not multiplication, right? It was addition of a negative, which is the same as subtracting. So now I have two groupings, right? This green grouping, and how about we'll use a red grouping. In each of those groupings, I'm going to factor out the greatest common monomial factor. So the greatest common monomial factor of that first binomial is going to be an x squared. And then what's left? X squared times what gives you this first term? X. And x squared times what gives you x squared? A +1. Awesome. So that came from factoring out the greatest common monomial from the green part here. All right, in the next section, the red part, the red grouping, what's the greatest common factor between -4x and -4? Well, it's -4. And what's really important is that I'm able to match the binomial factor that I've created here, just like I did up above. Okay, so if I factor out a -4, I'll be left with x + 1. Does that binomial factor match with what the other binomial factor is from the other grouping? It does. That's awesome. So that means I'm going to be able to take, let me highlight this for you. I'm going to be able to take out the greatest common factor of x + 1. I'm going to be able to undistribute that binomial factor. Okay, so let's do that. So I'm going to have 3y. Okay, and that was just my greatest common monomial factor to begin with. Okay, now I'll keep this in the brackets. You don't necessarily have to. I'll simplify it again one more time. So my greatest common binomial factor in the brackets is an x + 1. I'm going to factor that out. So what's left? Let's see here. Well, x + 1 times what will give me this first green grouping? Looks like I'm missing an x squared. And x + 1 times what will give me the second red grouping? It looks like I'm missing this -4. Okay, we're far from done. But here's one thing I am going to do. I'm going to rewrite it without the brackets because it's all multiplication. All right, so we're going to have 3y times x + 1 times x squared - 4. Guess what? I'm not done. Look at this factor. That factor, look, both terms are perfect squares, and there's a difference in between them. That is a difference of 2 squares. So I'm going to come up here, and I'm going to factor out that difference of 2 squares, right? That's like x squared minus 2 squared. That's me taking the square root of each term so that I'll get the bases so that when I factor this, my sum and difference pattern will use the x and the 2. So I'm going to end up with this equaling a 3y times the x + 1. And then I have to do a sum and difference pattern. X + 2 and x - 2. Whew, I think I'm finally done. That was a great problem. All right, you have all 5 factoring friends. Some of them are cooler than others, but make sure that you touch base with every single one of them as we move forward. You're going to need these going forward, not just in this unit, but really for the rest of your mathematical career. They're going to be great friends to you.